Seeking English S.A.T. Workbook, page 348, problem 2. Football costs $24 after a 20% discount. What was the original cost of the football? It says disregard sales tax. So it mentions tax and discount. That prompts me to go over this again. Why do I mention this again, and why am I going to mention it in additional videos? Well, because even my best students seem to need to have this mentioned to them and explained to them more than once, and often much more than once. I use the terminology of tax and discount for things other than money in other problems and other lessons, because money seems to be of universal interest. If the topic of, or the narrative content of the problem is not something that normally interests you, thinking about it as money might make it more interesting to you. So I use tax to describe one mountain being taller than another, and I use discount to describe decay of radioactive isotopes as if they're getting an annual discount. But it's just analogy. The analogy with money is helpful, and the test itself is nothing but a bunch of analogies anyway, so it's kind of fair. Tax, people tend to understand tax pretty well. If you have a number that's positive and you multiply it by a number that's larger than 1, that number will become larger. Discount, this part they understand well. If you have a number that is positive and you multiply that by a number that is smaller than 1, that number becomes smaller. Where they get confused is how to get the numbers that you use to multiply. How do you get your tax multiplier? How do you get your discount multiplier? Tax is a little bit more intuitively obvious. You take 1 and you add the tax rate to that. So if you have a 10% tax rate, you add 10% to 1 and you get 1.1. 1.1 or 110% is your tax multiplier. Okay, it's your original number multiplied by 1 plus the tax. This is where people get really confused. On the discount, you want to subtract the discount. Okay, subtract the discount from 1 to get your discount multiplier. So 10% discount doesn't mean you multiply by 10%. It doesn't mean you multiply by 110%. It doesn't mean what it means is you want to subtract 10% from 1 and get this multiplier 0.9. Then you multiply that to get your discount. Okay? Discount is not subtraction. It's not division. It's a multiplication process, just like taxation. The difference is if your multiplier is larger than 1, it's tax. If it's smaller than 1, it's a discount. Taxes make things larger. Discounts make things smaller. Other than that, they're the same. Your discount rate indicates the gap between the original and the new, but it's a negative gap. Keep that in mind. You have to subtract it. Okay. Think about what I've said some other time. In the meantime, it says a football costs. Yeah, we did this. This is take 8 of this video. Can you believe it? Wow. Okay. It says football costs $24. So I'm going to put this at the end. The order in which they give you things in this problem is not the normal narrative order, so it's not really the best way to understand them. You need to get them on the page or get them in front of yourself in an equation to deal with them. But if you understand that they're giving you the end of the story first, put the end of the story last and work backward from there if that's what they give you. In this case, that's what they give you. Okay, it says $24 after 20% discount. 20% discount, as I said, in this case, you subtract 20% from 1. Gives you 0.8 or 0.80. That's the number that you multiply by the original price in order to get the smaller price. Okay, I know that the 8 and the 2 don't look similar. Why do they call it a 20% discount? Well, that's the terminology that's used. Okay, so here, finally, at the end of the story, is the beginning of the story. It's your original price. Whatever the original price was, got multiplied by this discount multiplier at a discount rate of 0.2, which is discount multiplier 0.8, to give you a price of 24. From there you want the x by itself. So if you remember that if there's no denominator, this is actually a numerator. Okay, it means you can move this diagonally from this numerator position to this denominator position, 0.80. Okay? And then x is by itself. So except for the calculation, you're done. You have x by itself, you have everything else on the other side. Over here, it says in this problem you can use a calculator. Go ahead and use a calculator. While you're fumbling about, I'm going to do it this way. This is 4/5 of something. So 4/4 of 24 is 4/5 of that larger number. Yeah, really. So if you take 1/4 of 24 and you add it to 24, take 1/4 of 24 and you add it to 24, that's how you're going to get the larger number. 1/4 of 24 is 6. If you add it to 24, okay, you get 30. Is it really that simple? Yes, it is. So I hope you're done with your calculators by now. You don't have to do things the way I do them. I show that it's possible to do them. Just if it might be easier for you, sometimes it's slightly easier for me because when I was a kid, calculators were not abundant. But being able to see how to do it that way might be an advantage to you. Not because your calculator is broken or anything, but because it helps you see what's really going on in the problem. So if you have the time when practicing these, if you can do them, try to do them without a calculator first, and then double check with the calculator. If there's no time limit, forcing yourself to really digest and metabolize the problem gives you an advantage even when you pick up your calculator later. What's more crucial in this problem, what's more important is the tax and discount thing, which you're going to see me mention again if you keep watching my videos, and for the same reason. Also, the chronology, meaning if you put the events in the correct narrative order, if there is a correct narrative order, it usually will help you prevent yourself from telling yourself the wrong story. So this really was take 8. Take 8. Okay. I hope I will not be seeing you in take 9. Next problem.